Sparky here, ready to fetch the key points. Welcome to Belize's wild frontiers, from savanna sands to jungle deep. Let's make this short and sweet. Imagine stepping out of the dense, humid canopy of a Belizean broadleaf forest and into a landscape that feels entirely different. You are standing in the savanna, a vast stretch of open grassland dotted with solitary, thick-barked trees and wispy shrubs. To understand why this ecosystem exists, why the jungle suddenly stops and these open plains begin, we have to look beneath our feet at the remarkable and challenging soil that defines this frontier. The soil of the Belizean savanna is not the rich, dark loam one might expect in a tropical paradise. Instead, it is a study in environmental extremes, characterized by a unique physical and chemical makeup that dictates exactly what can survive here. The composition starts with a high level of acidity. These soils typically register a pH between 4 and 5, a level so acidic that it proves toxic or inhospitable to the vast majority of tropical plant species. This acidity is paired with a texture that is predominantly sandy and loose. In many areas, this sand is composed of silica dioxide, or quartz, minerals that are notoriously poor in nutrients. Whether these sands were derived from the granite heart of the mountains or deposited by ancient river systems along the coast, they provide a very thin, lean foundation for life. However, the true defining feature of the savanna soil lies just beneath that sandy surface. A few inches or feet down, you encounter a dense, impermeable layer of clay. This structural combination creates a dramatic cycle of water drainage, or a lack thereof, that changes with the seasons. During the rainy season, the clay layer acts as a subterranean floor, preventing water from soaking deep into the earth. Because the water has nowhere to go, the savanna becomes waterlogged, covered in vast seasonal sheets of rainwater. In these months, the savanna functions essentially as a wetland, with plants forced to keep their roots submerged for weeks at a time. As the season shifts and the tropical sun intensifies, the landscape undergoes a radical transformation. The standing water evaporates, and because the sandy topsoil cannot hold on to moisture, the ground dries out completely. The underlying clay bakes until it becomes a rock-hard, cracked surface, often referred to as hardpan. This creates a dual challenge. Plants must be able to survive both a flood and a drought in the same year. This harsh soil chemistry and the resulting drainage patterns are the primary reasons why the towering trees of the jungle cannot move into these spaces. The savanna is a frontier where only the most rugged, specialized species can find a home, all because of the unique interaction between acidic sand and impermeable clay. Imagine standing in a landscape where the horizon stretches out indefinitely, unblocked by the dense walls of greenery found in the nearby jungles. This is the structural reality of the Belizean savanna, a unique ecosystem defined by its openness. Unlike the tropical broadleaf forests that many associate with the region, the savanna is characterized by vast, rolling grasslands dotted with scattered clumps of trees or solitary pines. There is no overhead forest canopy here to provide shade or trap moisture. This fundamental lack of a ceiling creates a world of intense environmental exposure, where every organism must be built to withstand the raw power of the elements. Because there is no canopy to buffer the climate, the physical conditions within the savanna are remarkably harsh. The temperature and humidity on the ground almost perfectly match the surrounding air, meaning there are no cool, humid microclimates for sensitive species to hide in. During the day, the sun beats down directly onto the acidic, sandy soil, and during the rainy season, there is nothing to intercept the downpours that turn the landscape into a shallow, shimmering lake. This exposure forces a specific kind of physical architecture upon the plants. Most of the vegetation is tough, rugged, and relatively short. The grasses are wispy but resilient, and the shrubs are often gnarled, having adapted to survive in a place where food is scarce and the weather is unforgiving. The trees that do manage to grow here, primarily the hardy Pinus caribea and Pinus ocarpa, stand as the dominant structural features of the landscape. While some can reach heights of over 80 feet, many are stunted by the difficult conditions, appearing more like weathered sculptures than lush forest giants. These trees serve a vital role as the savanna's primary windbreaks. Without them, the winds would sweep across the plains entirely unimpeded, further drying out the soil and challenging the survival of smaller flora. This open structure also dictates the biodiversity of the region. Because life is so tough in the savanna, the ecosystem is naturally simpler than the complex multi-layered broadleaf forests nearby. There are fewer niches to fill and fewer places to hide, which means only the most specialized plants and animals can call this place home. The savanna is an ecosystem of extremes, defined by its lack of vertical density. It is a wide open passageway where life is lived in the light, governed by the rhythm of the seasons and the unobstructed reach of the Caribbean sky. This structural simplicity is not a sign of weakness, but rather a testament to the resilience of the species that have mastered living without the protection of a forest roof. Beyond their striking beauty, the savannas of Belize perform a series of silent but essential functions that maintain the health of the entire region. We often think of dense tropical jungles as the primary lungs of the planet, but these open, sun-drenched landscapes are equally vital for their ability to absorb greenhouse gases. The vast stretches of wispy grasses and scattered pine stands act as significant carbon sinks. By pulling carbon dioxide from the atmosphere and storing it within their root systems and the surrounding soil, the savanna plays a direct role in regulating the local climate and mitigating the effects of global warming. This process of sequestration is particularly impressive given the harsh conditions of the environment, where the vegetation must be incredibly resilient to survive the intense sun and nutrient-poor soil. Another critical service provided by this ecosystem is its sophisticated management of water. To understand how this works, we have to look beneath the surface at the unique geological composition of the land. Belizean savannas are defined by a layer of sandy, acidic soil that sits atop a much denser, impermeable layer of clay or hardpan. When the heavy tropical rains arrive, the water cannot easily soak into the deep earth because that clay layer acts like a waterproof floor. Instead of disappearing, the rainwater spreads out horizontally, creating what ecologists call seasonal rainwater sheets. This phenomenon essentially turns the savanna into a massive natural drainage system that manages immense volumes of water during the wet season. By holding these vast sheets of water across the flat landscape, the savanna prevents the sudden, destructive flash flooding that would otherwise overwhelm the surrounding river systems and broadleaf forests. This allows the water to be released slowly and filtered naturally, which is a vital part of the broader hydrological cycle. It is a remarkable display of natural engineering. The ecosystem is perfectly adapted to handle these extremes, transitioning from a parched, cracked landscape in the dry season to a shallow, shimmering wetland in the months of rain. Furthermore, the pine trees that dominate this horizon provide more than just a silhouette against the sky. Their specialized root systems are essential for stabilizing the sandy topsoil, preventing the wind and rain from stripping the land of what few nutrients it possesses. These trees also serve as a crucial windbreak, buffering the more sensitive inland habitats from the force of tropical storms. Even though the biodiversity might appear lower than in a dense jungle, the savanna functions as a vital biological corridor. It provides a safe passageway for large mammals like jaguars and tapirs as they move between different forest patches. By offering these diverse services, from carbon storage and flood control to erosion prevention and habitat connectivity, the Belizean savanna proves to be an indispensable part of the country's ecological infrastructure. To truly understand the mountain pine ridge, we have to look back millions of years at a landscape defined by dramatic shifts and constant environmental pressure. This area sits on a massive, elevated plateau ranging between 600 and 915 meters above sea level. This elevation creates a cooler, mistier environment than the coastal lowlands, with an average temperature of about 22 degrees Celsius. The story of this landscape begins deep underground with a foundation of ancient granite, an igneous bedrock that serves as the literal backbone of the region. This granite is often very close to the surface, and its chemical makeup dictates almost everything about the life that can grow above it. However, the surface of the ridge hasn't always been dominated by granite and sand. During prehistoric periods of submersion, this entire landmass was hidden deep beneath the ocean. During this era, a thick layer of limestone was deposited over the granite base, formed from the mineral remains of countless marine organisms. When powerful geologic processes eventually pushed the plateau upward, the land was finally exposed to the elements. This uplift triggered a massive era of erosion. Because limestone is relatively soft and soluble compared to granite, the heavy tropical rains, which average about 188 centimeters per year, began to dissolve and wash it away. In many parts of the ridge, the limestone was stripped away entirely, revealing the bare granite beneath. This long process of weathering left behind a very specific type of soil, shallow silica dioxide. This soil is essentially a byproduct of broken down granite, characterized by its sandy, gritty texture and a highly acidic pH level. It is also remarkably nutrient poor. In most parts of the tropics, you expect to see dense, broadleaf jungle, but here, the silica dioxide soils act as a biological filter. Most broadleaf species are unable to tolerate the high acidity and the lack of essential minerals found in this ground. This is the exact moment where geology dictates ecology. The harsh environment created by the granite and silica allowed pine trees to move in and become the dominant species, replacing the broadleaf forests that cover the rest of Belize.
The interplay between the granite and the remaining limestone creates a fascinating geological mosaic. While much of the limestone is gone, small pockets or islands of it still exist, particularly in low-lying areas or near the Rio Frio cave system. In these specific spots, the soil is richer and less acidic, allowing patches of broadleaf forest to survive right in the middle of the pine savanna. Furthermore, because the shallow silica soils sit on top of the mostly impermeable granite, the ridge acts as a massive collector for rainwater.
This makes the area a vital watershed, serving as the headwaters for many of the rivers and streams that sustain the central part of the country. When you observe the rugged beauty of the ridge today, you are seeing the result of a prehistoric sea meeting ancient volcanic rock, a landscape shaped by the slow, persistent power of water and the enduring strength of granite. When we move from the high elevations of the mountain pine ridge down toward the sea, we find that the lowland savannas of Belize are far from a uniform landscape. Instead, they are divided into two distinct regions with very different geological foundations that dictate everything from how water moves to what can grow in the soil. To the north, starting from Gales Point and stretching upward, the savannas are defined by what geologists call karstic topography. This means the landscape is built upon a base of ancient eroded limestone. Because the terrain in the north is so remarkably flat, the drainage is incredibly poor. You will typically find a layer of sandy topsoil of varying depth, but it sits directly on top of a very compact subsoil made of either clay or limestone. This structural sandwich creates a difficult cycle for any life form living there. During the rainy season, that impermeable clay layer acts like a basin, trapping water on the surface and creating vast shallow sheets of standing water. However, when the dry season arrives, the ground does not just dry out, it bakes into a hard, cracked crust known as hardpan. It is a world of harsh extremes, where plants must be specialized enough to survive being drowned for months and then parched in sun-baked clay for the rest of the year. As we travel further south into the Toledo and Stan Creek districts, the geological story changes entirely. Here, the southern coastal lowlands were formed not by the eroding bedrock beneath them, but by the relentless action of rivers flowing from the interior mountains. Over millennia, these rivers carried sediment down from the highlands, depositing what we now recognize as the old coastal plains. The soil in these southern savannas is primarily composed of quartz sand. While this sand may look clean and white, it is notoriously nutrient poor and highly acidic. Unlike the northern limestone base, which is essentially old seafloor, this southern soil is the result of mountain minerals being washed away and settled along the coast. This quartz sand does not hold onto nutrients well, meaning the plants here must be even more resourceful to find the minerals they need to survive. The contrast between these two regions is a perfect example of how geology dictates ecology. In the north, the challenge is the physical structure of the limestone and clay, which prevents drainage and creates a seasonal wetland effect. In the south, the challenge is the chemical makeup of the quartz sand, which offers very little in the way of sustenance. Because these lowland savannas are spread across different latitudes, the amount of rainfall and the average temperatures also vary as you move from the northern karstic plains to the southern sandy reaches. Yet the common thread remains a struggle for life in poor soil. Whether it is the limestone-based hardpan of the north or the acidic quartz sands of the south, these lowland environments are defined by their lack of minerals and difficult drainage. These factors together prevent a thick forest canopy from ever taking hold, leaving the landscape open, airy, and exposed to the Caribbean elements, creating the iconic open vistas that define the Belizean frontier.
In many ecosystems, fire is seen as a purely destructive force, but in the savannas of Belize, it is a fundamental engine for life and renewal. This environment is defined by a cycle that depends on heat and flame to maintain its unique structure. The dominant pine trees in these regions, specifically the Pinus caribea and Pinus ocarpa, have evolved extraordinary strategies to not only survive these intense events, but to utilize them as a biological reset button. One of the most fascinating aspects of this relationship is how the pines themselves actively contribute to the likelihood of fire.
These trees are saturated with pitch and resins, which are highly flammable organic compounds. During the peak of the dry season, which typically runs from March to May, these resins turn the trees into natural lightning rods. When a strike occurs, the resin ignites easily, and the fire quickly descends to the floor, spreading across the landscape by feeding on the dry, wispy grasses and seasonal shrubs. While the sight of a burning savanna might seem catastrophic, the mature pines are built for this exact moment. Their primary defense is a specialized, thick bark that acts as a heavy-duty thermal insulator. This bark protects the delicate inner layers of the tree, where water and nutrients flow, allowing the pine to withstand the rapid, high-heat passage of a grass fire. If you observe the older trees in the mountain pine ridge or the coastal lowlands, you will see the physical history of these events written on their trunks. Large, blackened fire scars mark the height of previous blazes, showing that these trees have stood firm while the world around them burned. But survival is only half the story. The fire is also a requirement for the birth of new trees. Many pine cones are held shut by a sticky resin that only melts at very high temperatures. As the fire moves through, the heat triggers these cones to burst open, releasing hundreds of winged seeds into the air. The timing of this release is brilliant. The fire has just finished clearing away the dense undergrowth, such as the aggressive tiger bush ferns and thick grasses that would otherwise choke out a young sapling. Furthermore, the fire converts the dead plant matter into a layer of nutrient-rich ash. This creates a perfect open nursery with mineral-rich soil and plenty of sunlight, giving the new generation of pines a significant head start. In the Belizean savanna, fire isn't an ending. It is a sophisticated mechanism of forest management that ensures the pine stands remain healthy, open, and capable of constant self-renewal, despite the challenges of the environment. While the Belizean savanna might look like a simple grassland at first glance, the true giants and architects of this landscape are the pine trees. They are much more than just scenery. They serve as vital windbreaks and anchors for the earth, using their sprawling root systems to prevent soil erosion in a land prone to heavy seasonal rains. In Belize, two specific species dominate the horizon, Pinus caribea and Pinus ocarpa. These trees have adapted to some of the most challenging conditions on the planet, and understanding how they survive reveals a fascinating story of biological cooperation.
The first and most widespread species is Pinus caribea, often called the Caribbean pine. This is a versatile survivor that you can find across both the lowland coastal savannas and the high upland ridges of the mountain pine ridge. If you are standing in a savanna and want to identify this tree, the secret is in the needles. Pinus caribea typically grows its needles in distinct bundles of 3. These trees are capable of reaching impressive heights of over 25 meters, though in areas where the soil is particularly acidic or poor in nutrients, they may appear stunted and gnarled, reflecting the harshness of their environment.
The second species, Pinus ocarpa, is much more exclusive. In the context of Belize, you will only find this tree in the upland savanna systems. It is restricted to higher elevations like the Mountain Pine Ridge Plateau. You can tell it apart from its lowland cousin by counting the needles in each bundle. Pinus ocarpa carries its needles in groups of 5. Survival in the savanna is a constant struggle because the soil is acidic, nutrient-poor, and lacks the basic ingredients most plants need to grow.
To overcome this, these pines have developed a remarkable biological partnership. Interestingly, these pine trees lack traditional root hairs, which are the tiny structures most plants use to absorb water and minerals. To compensate, they have formed a symbiotic relationship with mycorrhizal fungi. These specialized fungi attach to the tree roots and extend a massive web into the surrounding soil. The fungi are incredibly efficient at breaking down organic litter and extracting precious nutrients that the tree could never reach on its own.
In return for this service, the pine tree shares the sugars it produces through photosynthesis with the fungi. This underground trade deal is the only reason these massive trees can thrive in such a demanding landscape. Their resilience is also tied to the element of fire. Both species are rich in flammable resins and pitch, which often attract lightning during the dry season. While fire consumes the underbrush, the thick, tough bark of mature pines protects them from the heat. This cyclical burning is actually essential for their population. It clears away competing vegetation and creates the perfect conditions for a new generation of pines to take root in the nutrient-rich ash.
From the microscopic fungi on their roots to their fire-resistant bark, these two pine species represent the enduring spirit of the Belizean wild frontier. While the towering pines might be the most visible feature of the Belizean savanna, the true story of survival is often found much closer to the ground. In an environment defined by acidic, nutrient-poor soil and cycles of flood and fire, the non-pine flora has developed some of the most ingenious adaptations in the plant kingdom. Because the soil lacks the basic minerals most plants need to thrive, these species have had to get creative, sometimes even looking beyond the earth for their food. One of the most fascinating examples of this is the sundew. Found primarily in the upland savannas of the mountain pine ridge, the sundew is a tiny, unassuming plant that is actually a sophisticated predator. Because the sandy soils are so depleted of nitrogen, the sundew has become carnivorous. It features small, sticky blossoms that glisten like morning dew, but for a passing insect, these are a deadly trap. Once an insect is stuck, the plant slowly digests it, extracting the vital nutrients it can't get from the ground. It is a perfect example of how life finds a way to balance the scales in a harsh landscape.
Moving up in scale, we find the savanna oaks. These aren't the massive, sprawling giants you might see in a temperate forest. In the Belizean savanna, oaks are rugged, low-growing trees with gnarled, corrugated bark and rounded leaves. They are built to withstand the intense elements of the open plains. Interestingly, their survival is closely linked to the acorn woodpecker. The woodpeckers collect the oak's acorns and stash them in the holes of nearby trees. Because the birds often forget where they've hidden their haul, they inadvertently act as the primary planters for the next generation of oaks.
In the lowland savannas, the craboo tree is a standout species. You can identify it by its dark green leaf clusters and its small, bright yellow berries. These berries are edible and a local favorite, but they are even more critical for the resident wildlife, particularly the iconic yellow-headed parrot. Another distinctive resident is the yaha shrub, which locals often call bush sandpaper. If you were to touch its leaves, you would immediately understand why. They are incredibly rough to the touch, a physical defense mechanism that makes them less than appealing to hungry herbivores. Closer to the ground, the landscape is often dominated by the tiger bush fern, also known as the doublehead fern. These ferns form dense, low clumps with compound leaves that split into 2 distinct points. They are incredibly hardy, often covering extensive areas of the mountain pine ridge where other plants struggle to take root. You might also spot the mountain orchid, which is a bit of a trickster. It doesn't grow on trees like many other orchids. Instead, it grows straight from the ground on a tall, bamboo-like stalk that can reach up to 3 meters high, topped with a large, showy purple flower. From the spiny trunks of the palmetto palms to the bright yellow blooms of St. John's wort, these specialized plants prove that even in the poorest soils, biodiversity can be remarkably rich if you know where to look. While the open vistas of the Belizean savanna might initially appear quiet or even empty, a closer look reveals a world teeming with specialized wildlife that has adapted to this challenging environment. Unlike the dense broadleaf jungle where life occupies every vertical layer, savanna fauna is often more elusive, requiring a keen eye to spot. The most immediate inhabitants you are likely to encounter are the insects. During the rainy season, temporary ponds form across the impermeable clay layers, creating the perfect breeding ground for a buzzing population of mosquitoes, botlaws, doctor flies, and horseflies. These small but persistent creatures are a fundamental part of the food web, providing a vital protein source for the many lizards and birds that patrol the grasslands. For reptiles, the savanna's dry, sun-drenched landscape is an ideal home. The spiny lizard is a common sight, acting as a low-level predator that dart across the sandy floor. You might also spot the fast-moving tropical whipsnake, a slender, light brown hunter that pursues lizards and small mammals through the grass. However, the most iconic and formidable reptile here is the cascabel, also known as the Central American rattlesnake. This active pit viper is easily identified by the two dark brown stripes running from its head down its neck and, of course, the distinctive rattle at the end of its tail. As a mid-level predator, it uses hemotoxic venom delivered through long, hollow fangs to hunt its prey. Despite its fearsome reputation, the cascabel is a vital component of the ecosystem, helping to regulate the populations of rodents that pass through the area. Mammals in the savanna are often more transient, frequently using the open landscape as a corridor between patches of broadleaf forest. However, a few hardy species call this place home. The nine-banded armadillo is one of the most unique residents. These nocturnal creatures are armored with gray to yellowish plates and are famous for their ability to curl into a protective ball when threatened. They are fascinating biologists because females almost always give birth to 4 identical young from a single egg. Armed with powerful claws for digging, they spend their nights rooting through the soil for ants, termites, and fallen fruit.
Joining them in the twilight hours is the gray fox. Unlike many other canines, the gray fox is an adept climber, using its hooked claws to scramble up trees to sleep or escape predators. You might also catch a glimpse of the white-tailed deer. These Belizean deer are notably smaller than their relatives in North America, but they are incredibly fast, reaching speeds of up to 30 miles per hour. When they sense danger, they raise their tails to flash a white underside, serving as a silent alarm to others nearby.
Whether they are armored, venomous, or incredibly swift, the animals of the savanna showcase the incredible resilience required to thrive in Belize's wild frontiers. Looking up into the open sky of the Belizean savanna, you will find that the birds here are as specialized as the landscape itself. Because the savanna lacks a thick forest canopy, the birds you see are often either small and elusive or large and highly conspicuous. Among the most celebrated residents is the yellow-headed parrot, a bird that has become a true icon of the region. Measuring about 37 centimeters, these parrots are easily identified by their bright yellow faces and crowns, which contrast sharply against their green plumage. They are particularly fond of the savanna's krabu trees, often gathering to feast on the small yellow berries. These parrots are highly social and vocal, known for their distinctive rolling, rapid-fire gurgling notes that echo across the plains. As one of the 9 parrot species found in Belize, they play a vital role in the ecosystem by nesting in the hollows of pine trees and helping to disperse seeds. While the parrots dominate the visual landscape, the acorn woodpecker represents the savanna's resourcefulness. These birds are striking with their black and white bodies, red crowns, and oddly patterned faces featuring pale yellow throats and white eyes that give them a wide-eyed appearance. True to their name, they are obsessed with acorns provided by the rugged oak trees scattered throughout the savanna. However, the acorn woodpecker is more than just a gatherer. It is an engineer. They drill holes into trees to stash their acorns, but their primary goal isn't always to eat the nuts themselves. Instead, they often return to these granaries to eat the insects that have moved in to consume the stored acorns.
In an interesting twist of nature, their habit of hiding acorns in various places means they sometimes forget their caches, which helps the oak population regenerate as those forgotten acorns sprout into new trees. The savanna also serves as a crucial crossroads for international travelers. From September through April, the landscape is filled with North American migrant species that seek refuge in the warmer climate. Many of these visitors are insect-eating warblers, which take advantage of the seasonal abundance of insects that emerge from the savanna's temporary ponds and grasses.
You might also spot the hepatic tanager, a bird with a stout, dark bill and dull red plumage, feeding on fruits and seeds alongside resident specialists like the black-headed siskin and the vermilion flycatcher. Even rare predators, such as the orange-breasted falcon, utilize these open spaces for hunting. Whether it is a permanent resident like the yellow-headed parrot or a passing visitor, each bird in the savanna has adapted to the wide variations in temperature and the open exposure of this unique environment. Their presence reflects the connectivity of the savanna, acting as a bridge between the deep broadleaf jungles and the coastal lowlands, and ensuring the continued health of this vibrant frontier.